we have uploaded something. You want to look into this, or
I have
which one is that? This one here, or this one? Okay.
That was automatic alignment, right?
Yes.
And I wondered what model is it is because it's so bad.
It's bad.
Even in English, the first sentence, the today.
The today.
Yeah, what is this? Even in English, it's not good.
Well, I
sometimes it's correct.
for instance, is
no, nice.
Nice. Okay.
Yeah, nice. Or cream in the second. Yeah, it's yeah. But what kind of model is it?
This is from the group in, I think in Stuttgart. They produced a program that's called SimAlign, and they have three kinds of parameters: SA, SI, and SM. And the best one for us, the best was SI actually, and you can test those. So it's an automatic alignment, and of course it contains all the 100 languages or so, 100 language pairs, and maybe for Korean it doesn't work. Obviously, it doesn't work very nicely. So that's possible. But okay, so you can still try either the other automatic alignment parameters, SI or SI, perhaps, or manually align. So you did this and the other, and that worked, yeah. So it's this one here. Okay. The weather is nice today, and the final stop could also be aligned here, here and here. Could also align the stop here. Okay, so you can click on done, and if you go back here, you can you see it became red. You can click on save alignments. It will. So there's actually two parts in this database. There's one part that is for visualization. The data is for visualization, and one part in the database. And when you click on save alignments here, it's transferred from the visualization tool into that actual database. Okay. So if we download, for instance, your alignment, so we have created these alignments here. So you have one session, right? P01T1, and there are these three files. For each session, there are three files that we can look into with here with Notepad. And the first file is the SRC. It has a SRC extension here, okay? And that is the tokenization of the source file. And you can see here the different tokens. This is the weather is nice today. Let's go eat ice cream. Full stop. Okay. And then you have a segment ID here. So this is the first segment. This is the second segment. And then you have a word ID. And the whole text has it's just numbered from 1 to N. So there are 13 words or tokens in this source text here. And then you have a cursor position. That means that this word starts at position 0 in the text, and then you have 3 characters, right? Then you have a space here. This is the space that precedes this word here. And the fourth character is then this second word, which should actually be WEA, no? Weather. but never mind. So the weather, this is a homophone. Never mind. So this starts on position 4 in the text, okay? And then 4, 5, 6, 7, 8, 9, 10, 11, and this word starts at position 12, and so on. So this actually gives an account of the words that are there, the segmentation of the sentences, and the spaces. So there may be one space or maybe a couple of spaces, then this would change accordingly, right? And the idea then is that eventually we will have, okay, so now I go into this target. So this is the source text. This is the target text, and here is the same structure, okay? So you didn't give a language here also, so you didn't click. If you had clicked language English, then there should be an EN here, and there should be, but we don't have Korean in this drop-down menu, so you could do there something that Yusheng did by just filling in this XML tag. But anyway, so here should be the KR, is it? For the language tag, KO for the language tag. Here is the same thing. So you have the words, the segmentation, then you have the segments, 2 segments. And as you can see here, the number of segments should be identical on the left and the right side, right? For have the segment alignment. And here you have the cursor positions, means the offset in the text. Then you have this file here. This is the alignment. That is the relation between the source and the target text. Here it says that this is the source file and this is the target file. So that's just what we looked into, right? The 2 files, the source and the target file. And here it says the source file is associated with key A, and the ID 5 in the source file is linked or aligned with the first word in the target file. Can you see this? Means that, for instance, the target file here, B, okay, word number 2 is linked or aligned to word number 1 and 2 in the source. Okay, here the first Korean word is aligned with the 5th English word, source word. Okay, so this gives all the alignment relations that we previously saw here. Where is it? So if we go back here and we look into this again, and then we look into, for instance, the weather. This is word 1 and word 2 in the source is aligned to word number 2 in the target. So it means the word 1 and 2, right, is the weather, is aligned to word number 2 in the target. Make sense? Okay, so we can have actually any kind of alignment here with this representation. Now, if something goes wrong, for instance, if you had a wrong, okay. So this is the word alignment. This is the alignment on the word level, and this is the alignment on the segment level. So here it says that the source segment 1 is aligned to target segment 2 if the source segment 2 is aligned to target segment 2. Means these seg IDs, right? Now we could have a case where you have several sentences in the target language, for instance, that should be aligned to one sentence in the source. Then one could just go here and so assume you had 3 source sentences, okay, and the second and the third source sentence would be aligned to the second target sentence. You could express this something like this, Okay, and then you would have maybe two sentences here with another stop, and that would be aligned or appear in that box in one box here. Okay. Because the thing is, you can only word align stuff that is in one box. You cannot align the weather here, for instance, with something here on that side. Right, so you can only align stuff that appears here in a source target box. And that's one way. So if you have several sentences, 2 or so sentences that are actually translated into one on the target side, that's a way to remedy this, that you could say these 2 sentences appear on the left side in the box, right? And they are aligned to that one sentence in the target side. Okay, I mean, we can look into this eventually again if some cases pop up like this. Okay. Any questions? No?
I have a question.
Okay, sir.
Okay. Yes.
Let me go first. What if there is a null alignment, so a word in the source, but no equivalent in the target?
Yeah, we had this here previously. Then it would just not be aligned, right? So, so if you go here, there were a couple of, sorry, well, we aligned this whole thing. But I mean, we could say here, dissolve alignment group, and this would not be aligned, right?
Mm-hmm.
That's possible. But of course, the idea is that if we do this alignment to explain how the source target relations come into being. Now, if we leave stuff unaligned, then we don't have an explanation for this, no? So if we would not align something like this, right, then we would say there is an item on the source side that mysteriously has not been translated, or has not been translated, and there is an item on the target side that was just inserted out of some mood of the translator or something. But we would not be able to explain this. Relate the behavioral data to those kinds of alignments. So we will later see that we have keystrokes that have produced this target word here, right? For instance. And then we can say the number of keystrokes that were used or necessary to produce this word are actually necessary to produce the translation of the weather into Korean. The production of the translation of the weather into Korean needed so and so many keystrokes and deletions and time and so whatsoever. Couple of parameters, and if we don't have this alignment relation, we cannot explain this. I mean, that's also, you know, a statement that there is so many words, for instance, in a translation that are not translated, or so many words that have been invented by the translator that have no relation to the source. That's also a statement. And we can make the statement, and so much time actually from there one can eventually maybe infer that for a translator he produced so and so many keystrokes to produce something that is not related to the source, for instance.
Can I correct the alignment manually if the first source text doesn't align with the first target text? When I open the file, I find the first text is aligned with the third target text segment. So it is possible to correct it manually and then upload it to the website?
Yes. Yes. So you were saying that what the first segment is aligned with the third target segment.
Yeah.
So that would be something like this, right?
Yes, this problem, and some of the
And what
segments
happened to
are
the target? What happened to the target 1 and 2? So maybe you would like to collapse this first source segment into, so maybe you want to collapse the 3 target segments into all align that to the first segment in the source.
Okay, I got it. Thank you.
And then it would go on like this, no?
Yeah.
Okay, so one thing is, so if you do these changes here, okay, you would save this file. Okay, let's do one thing. Let's say we want to map the 2. So we have two segments in this experiment, right? And we say here that the first segment maps into target 1 and 2, and the second maps into 1 and 2. Means the 2 segments are actually merged together, so they would all appear in one box. Okay, I save this file, then I can go here, and I think it's this file. I can zip this, zip. I zip this file, okay, only the alignment file. And then I can go back here to this session here. I choose the file. Where was it? Here, I choose this file, and then I put it on top of this GA. What is it? Like this, okay. And so this file here only contains the zipped ATEC file, right? And I guess it should be okay if I just upload this. I didn't try this for some time. Now, if we look into this guy again, and here, see, it's merged. The 2 files are merged together, right? The 2 segments are merged together. All the words are still aligned here, okay? But now we tell this tool that that the 2 segments are actually aligned. Of course, this makes the analysis later less precise. Now we could say that, you know, all the words align to all the other words in the other side and vice versa, but then we would have a less precise. So the idea would be to have it as fine-grained segmented as possible on the word alignment level, but also on the segment level. Okay.
Yeah, thank you.
I have put a script here, progression graph. Okay, if we load this, then something like this pops up. And this is basically, it's the same thing that would actually usually run on the server, but only here it runs in this. This is R. It's not Python. It's R. And in this Jupyter notebook, we can run actually R or Python. Here we have Python and R, and in this case we have R code. So there is a code. This one here, which has 2 functions: read data and plot the progression graph. That is read, and well, usually it would work on the server, but right now I need to do this manually to show you these graphs. Then we can just read a session, and this is the path to the database, to this translation process database. So as you can see, here is a directory called TPR-DB, and below we have a user called BML12. Our user, we are summer 2023. Okay, so we are just another user. And then we have these tables here, and there is a session called P06T5. I load this session here. Okay, and then I can plot it. And this is what Yusheng already showed yesterday, and maybe some of you have seen this on a translation progression graph. It's not the best format here. This is a little bit, it's better if it's on the browser. And if you run this in RStudio, still you will see slightly different rendering. But this is the translation progression graph for this particular session. And you can see here this text consisted of 140 words approximately, and then it had 6 segments, 6 segments. It means the segment is the one that it's not a sentence, it's the segment that we have in this Yawat tool, which are aligned. So it can actually have various sentences in one line, but usually it would be one. If we assume that every sentence segment, every sentence translates in every sentence, then this would be correspond to the number of sentences. Okay, so here is the translation from English into Spanish. And we can see here that first we have this drafting phase where the translator reads, and blue dots is the fixations on the source side, and green dots are the fixations on the target side, where the translations pop up on the target window. And then we have here a kind of a revision phase where mostly the eyes are on the source or on the target side. In red, we have here kinds of corrections, revisions, here too. And so we actually see here two, so one revision phase and another one here, okay? Now one can zoom into this part. So here, my idea was you can zoom into this part and look more into detail what happens here. And one can give here the X. So this is the X-axis. This is the timeline, right? So we look into a chunk of time between seconds 30 to 80. Okay, so this is somewhere here, 30 to 80. And this is what we can see. Here is the segment 3 starts. Here the translator just finished translating the segment 2, then starts translating segment 3, and first thing reads the segment, then gets stuck a little bit up here and rereads and refixates these words at the end of the source text, and then starts drafting here or translating by again looking at the source, and then while quite fluently typing here the translations. And then in red we have here some deletions. In red would be the deletions, in black the insertions. Okay, and what you can see here is the word alignment. Okay, so that's increasing, was aligned to these 3 words in Spanish. Okay, mobility into 2 words with an article, the mobility, and so on. So if you can directly see here the impact of segment alignment and word alignment within segments. So here we have the segment alignment, okay, the lines, these horizontal lines, segment, and here we have the word alignments, okay. Here this progression graph shows the source text from bottom up, okay, in the order of the source text, increasing mobility and technical advances and so on. So this is the English sentence, and here it is aligned to the Spanish, but in English syntactic order, okay, according to that order of that site here, right? Okay, and now you can also see that we can map all these behavioral data. So we have behavioral data here on the x-axis, right? Fixations, basically fixations on the source text here increasing. Here we have a fixation on the Spanish translation of increasing. So this part of this word, this chunk here. And then we can map all this together. So we have directly a relation between the source word and its translation and the behavioral data that was associated to this translation equivalent. You can see that here are a number of insertions, here is a little bit of reading, and so on. So you can see that we can actually put all this into relation, the source words, the target words. Here, for instance, we have a 2-to-1 translation relation resulted in, okay, these two words are translated into the same word here, Spanish, which is, well, it's a 2 source words translated into 1 Spanish word. Here we have 1 English word translated into 2 Spanish words, right? So we have M-to-N relations, translation relations, and the behavioral data that can be mapped onto those relations. Now we can look more into detail here, still looking into that segment between 40, so that would be 45,000 to 55,000, somewhere around this part here. If we look into this, it's this thing here. So you can see how this Spanish translation of increasing emerges in time, how the translator reads while typing. Okay, so the translator writes the translation of increasing mobility while looking at the source text, and then goes back to the target side and focuses on these words, and then types goes on. And here you can see this kind of syntactic inversion and the whatever. So this is aligned to advances, 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 and so on. Okay, then in addition, we can chop up. So this is actually a flow. Okay, it's a sequence of, it's a flow. It's actually 2 streams. It's a stream of keystroke and a stream of gaze data on the source and the target side. And one can fragment this in the timeline here. And here is what has often been referred to as translation unit. So we have here in this gray bar here is a sequence of typing that is not interrupted by a longer pause. Okay, so this stretch of time here, in this stretch of time, all the stuff was typed and quite fluently. And the definition of fluent typing is that there is no pause between successive keystrokes of more than 1 second. Okay, so there is no pause of more than 1 second between any consecutive keystrokes in this stretch of time. That would be one definition, maybe, of fluent typing. Okay, and here then there is a pause. And so you see these durations here. This duration of this fluent typing is 4-point-something seconds. And then we have a pause here. And then we can do the same thing with the gaze data. We can say that there is a fluent reading on the source side. And then we have here reading on the target side. Then the gaze goes back to the source, to the target. And so we have 2 streams that we can then, in which we can segment the stream of data. And here we have something that we called activity units. So we can actually fragment this stream into concurrent reading and writing and sequential reading and writing. So concurrent means the translator reads on the source or the target while typing. And then, of course, here in this part, the translator reads but does not type. And it would also be possible in principle that the translator types without that the gaze is recorded, the gaze data is recorded. So because maybe the translator looks to the at the keyboard or something, most likely. So yeah, so one can also have stretches of data where we don't record gaze data but only keystrokes. Okay, so these progression graphs are quite interesting to get an overview of what happens, how the translation goes on. Okay, so any questions with respect to this?
Could we apply
No?
that? Could we apply that R script to our data?
Yes, I was just about to do this. If you go into the summer 2023, okay. Okay, no, sorry, it should be actually here. Okay, and then we have this I'm taking your data, okay? So we don't, of course, here we don't have gaze data. We only have typing data, right? And you can see she has, so you take away the extension. So this would be the session name. So this is the user. We are all user. Can you see that clearly enough? Yes, we are all user summer 2023. Okay, and so we have loaded this data, and now we can plot this data. And you can see here, well, there was a problem with this non-Latin character set. There's a solution that Takanori found out, but it's not right now here. So this would be the characters typed. And we see these two segments. Okay, and here we see the alignment. I guess you know what this would be, right? Because, and here we see, but how the translation evolves in time. Doesn't make very much sense for for us.
Professor?
Yes.
So I wonder, should we copy that script that you have under the shared folder? I guess we should make a copy into our own subfolder and then run it from there with our data.
Yeah, that's. I was also thinking whether this is actually needed, because you would not really change the code. You could also run it from there, but you can copy it into your. So that's only this one here, and you load the source code. This one you can leave it there, right? So you don't need to copy this. There are very many versions of this progression graph script. One is this one here. Yeah, you can either run it from there or copy it into your folder. That's possible. I will rewind your this wrong annotation or this block segmentation, right? Okay. And upload this again. So I have redone this into the previous version, zip it, and then if I upload this here again, I hope it will go back to the original version. So let's see. Okay, so we are back where we were in the beginning. Now, what we can do, annotation of this data. So we can here, maybe you have seen this already. So there are different kinds of error annotations that we have. And can everybody see this good enough? And so this tool is good. This Yawat tool is good for aligning segments, but we can also annotate errors. And here we can annotate fluency errors. So there's two modes actually that we can use. Here we can say, well, maybe this is a mistranslation, and this mistranslation can be minor or critical. There's a cohesion error, word form, word order, punctuation mark, or spelling error, right? So, and what one would do here, one would annotate a word group. Okay, so we know that this is a translation relation somehow, and we say, for instance, here this is a mistranslation. It's a so it's well, maybe one could find instances where one can say that this is a translation, but actually it's a mistranslation, right? So we can align these words and say this is a mistranslation, or we can say here whatever, no? So maybe we can have a spelling mistake and so on. It is possible to configure these errors, this taxonomy here. We will see this eventually. But it's also possible, so we can also dissolve this alignment group here. And then we have different kinds of errors, right? So here we align, we assign an error, or it must not be an error, an annotation. We annotate an alignment group. For instance, if you are interested in metaphors or in terms, difficult terms, or whatever it is, you could change this taxonomy here and say you align whatever category you want to align here, okay? And then here we have a bi mode where we have a bilingual alignment, and here we have a mono mode in which we can align this monolingual. So we can say here it's an addition or an omission. So we put this here, addition or omission. Why? Because it's an omission if it's on the left side. Okay, so you, for instance, you would say is not translated into the target side. So if it gets this label on the left side, then it's an omission. Something was left out. If it gets this label on the right side, the color is the same, but it's an addition, right? Because here the translator inserted some stuff that was not on the source side, so you could annotate this as an addition omission, or you could say, well, this is you could say this unintelligible, so it doesn't make sense. What I mean, it's just examples for an error taxonomy. This was useful for one research project that we had, so it's we have this here, this taxonomy, but we can also change it.
I have a quick question, Professor.
Yep.
We didn't really talk about the other tables that are output by the server analysis. you showed us the 3 alignment tables today, but the 3 alignment files. But if we
Yes.
go into our, if we download the tables after make tables, we get about 10 files or so. And I think Yuxiang showed us 1 or 2. But I wonder, is there any
Yes.
documentation for what the other files contain and what we can do with that information?
There's much data on that CRITT website. If you go into this publication here, introduction, this chapter here contains a quite detailed description of the various features that there are. And you can, I think you can download this book from here. This is the link to the website, download here, okay? If you download this here, you can get the book, and then you can go into that chapter 1, and it gives you a description of the features in that database. Of course, this is a couple of years old. It's how much? 6 years, and some things have changed. If you're unhappy with this, you can also go into this features section here, and here you have an exhaustive list of the features in that database, in the tables. You can select a table here, for instance, this table here, and you can, for instance, and then you can select a feature, and there should be a description of what that feature is. So, for instance, there's feature door 1 and door 2, and it says what this feature is. Not very, I mean, a very short form version of it. Okay, but it should have almost all features, only the most recent ones perhaps missing.